This video is for the newly developed, patent-pending CDSS systems and software universal benchtop crimping machine. The UNI-CRN, we found that the space was full of products claiming to be universal, but in reality, they weren't in any usable way. And we've been chasing this particular outcome, a machine that can run everything that the crimp tool can run for a very long time. And what made it possible is that instead of a bespoke mechanism that runs a single machined aerospace contact like these, we have a mechanism that is designed to run a range of them. And while that mechanism does the part handling, the actual granular sorting to allow us to make sure that the wire barrel arrives at the crimp head first every single time is done by a state-of-the-art AI machine learning camera. And that vision system, coupled with our mechanisms, have allowed us to build the machine that you all have been asking for 30 years. Now, a lot of these things look the same as other CDSS systems, crimping machines that you might have seen or even have in your facility. Like always, the crimp head over here is built around a DMC crimp tool. This is the spec AEROSPACE tool, the Daniels Company AFM8. We buy it right from Daniels, and we don't do much to modify it. We open up the little housing here a little bit, you know, so we can get funnels and the contact stopper in and out of it. The things that do the work of the crimping, the ratchets and cams, the selector knob are untouched. This knob just extends it so you can get at it from the front side, and you know, we feed the parts from the back as opposed to dropping them through the front, and we make positioners also sized for a range of parts. So this module here is for parts that are in about the 20 gauge range, and the positioner in here is likewise for parts in about that 20 gauge range. This is a positioner that's smaller, but it shows you what they look like. This is for 22 gauge range parts, and what you can see here is that the positioner very carefully and tightly centers the contact in the crimp aperture, and the slots here allow the indenters to pass through, so it's centered right at the most important part. This allows it, the crimps made by our machine, to meet even stringent TIR requirements. Parts pass through this, they eventually wear out. This is a replaceable wear part, but on the universal machine it's also interchangeable to allow this same crimp tool and setup to process a wide variety of parts with minimal change out. The contact stopper, which we developed for termination of very short lead multi-conductor cable, often used in aerospace and satellites and other applications, also had the feature of being adjustable. So with our funnel jaws, the crimp location is set, but with the contact stopper here, that screw can be turned in and out and locked at a different position to be able to put the crimp exactly where you want it, and also allow you to run different parts and put the crimp in the right spot without having to put on a new set of funnel jaws. So everything about the system is designed to be versatile. Another difference you'll see immediately from our normal machines, our older machines, is that there's not a control cabinet on the base plate here. We've designed and built our own control cabinet that sits underneath the machine to keep the footprint small. It also means that for change out on this machine, you can get at it from all different sides. The various controls for the bowl speed and the grip regulator, and for that matter the main air pressure coming into the machine, are all easily accessible on the back side, along with power. Foot pedal is here. It's long, it's normally on the floor, but I've put it up on the bench so you can see it. And the other thing that's new about this is that in addition to a PLC to run the basic cycle, this is not just a touch screen, this is a Windows 10 PC. And Over on the left side, you'll see the vision software running, looking at the parts and identifying which way they're pointing. Over here, you'll see our software, which is a series of indicators showing what the various sensors see, the ability to pause and restart the system, switch between programs, and there's diagnostic troubleshooting that pops up of where there'd be an error. But what makes it all work is that these camera programs in the vision system change out very quickly. So this part is the, it's a MILSPEC pin. It is a 11-145. And if you look up here, you'll see that the program running is the 11145. Now if I resume the system running, and then I hit the pedal, contact is fired over to the crimp head. It's gripped with low pressure air. I insert a wire, I hit the pedal, and fires another contact. When the operator is using it, the interface is the same as a normal C-Davis crimping machine. However, when I want to change out to a different part, I would do my last crimp, hold the pedal down, pause the system, and then I would empty out all the parts in the bowl, put in the new ones, and then change the camera program to run the new part. It's also possible, depending on how physically different the part is from what I'm running to what I want to be running next, that I might have to move around some of the various adjustments on the system to include changing the crimp location with this screw, changing the crimp depth setting on the Daniels tool. If the part is substantially longer or shorter, I might need to move where this air gate is positioned. And likewise, if the ferrule, the wire barrel of the part is very different, I also might need to change the grip pressure off to the side and maybe even the bowl vibration. But that and changing the camera training program is all that it takes to change it out. And that might sound like a long list, but it can be done in 2 or 3 minutes. And making a new camera training program for a new part can usually be done in about 5 minutes. It's really quite simple, and it allows one machine to run nearly anything that the Daniels tool is designed to crimp. This was developed specifically to meet the needs of the high mix, low volume job shops who are our customers. And I know that most of you need to show an ROI on a piece of capital equipment. Pencil out within a year or two. And that means you need to be doing a lot of the same part. You need to be running a big job or have a reliable stream of similar or identical jobs to be able to justify a piece of capital equipment to process that part. And as a result, I know a lot of what job shops do is using hand tools like it's 1945. And I didn't really have anything to automate your process that you'd be able to use for most mil-spec parts that came in your door until we developed this system. And we developed it specifically for you. So I'm going to cut camera, I'm going to change out to another part, at least remove these pins and put in something else. And then once the parts are in the ball, I'll show you what the change out looks like on the machine. Okay, so I've gotten the old parts out, and now I'm going to put in a much larger socket. This is the 56351. So put some of these in the bowl here. Oops, trying not to make too much of a mess. So I got one in there. And I'm going to have to move a couple of things around on the machine to accommodate the new part. It's got a pretty similar wire barrel, so I don't need to do much, but one thing I have to do is I need to take this air gate and I need to move it a step further out. So the purpose of the air gate, if you don't know, is to keep parts from chaining together if they're pins. It also keeps the bunch of parts traveling up the bowl from bunching in too tightly and jamming the mechanism. So I'm going to start feeding them up the bowl now so we can get them to climb up the tracks. I'm also going to take this opportunity to adjust the bowl speed a little bit. Doesn't take much, but there's a particular rate that I want them to travel at, and that's right about where it is. So I'm going to stop there and let them get a little bit too far. But you can see now that one of them is loaded into the shuttle. Now I'm going to switch to a different program, because right now I'm in the 11145 program, and what I need to be in is the 56351, which is this program. So I'm switching to a different program, and as soon as I do that, the new camera program has identified that there is a part present, that the shuttle is safe to articulate, it's not going to crash because it's not obstructed by anything, and that the wire barrel is not first. So that's the camera telling me which way the part is oriented. The ferrules are similar enough that I'm not going to need to play with the grip pressure, but that's very easily done, and there's a gauge on it, so you can find the setting again. Now if I look at the length of the ferrules on these two parts, they're actually, the part that we've been doing is a little bit shorter, so I probably should adjust this out just a little bit. I'm just going to spitball it here. Normally you do a couple of test crimps to find out. But, if you're running a lot of the same part, you can get a fixed length positioner and just screw that in. The parts have about the same diameter, so I don't need to change out the actual positioner. The crimp setting is about the same. I'll just leave it at 5. I'm not sure whether that's the right one. And given that the fiber optic sensor still reliably sees that part show up, we should be good to run. I'm going to resume running. Then I'm going to fire apart. And we've now fired a 56351. And once the limited changeout is done, the operation returns to being very simple. Insert the wire, hit the pedal, remove the crimped terminated wire. Even if the technicians running the machine don't have the technical chops to do the changeout, once the machine has been changed out by a lead tech, for an example, they don't need them. All they're doing is running a standard benchtop machine. They're going to insert a stripped wire, they're going to hit the pedal, and they're going to remove a terminated wire. In our experience, a machine like this, that's feeding and handling the parts and doing a powered crimp, makes a technician 3 to 5 times as fast, depending on the speed of the technician, and by how delicate the wire is and how hard it is to bullseye that ferrule. The other thing you might want to know is that this Windows 10 PC on an ARM is not strictly necessary to have connected or running when the machine has been set up. This system is designed so a lead tech with a laptop can go from station to station, switch out to the parts you want your operators to be running, and then when the operator is running, there's no need for a computer screen. It would only be necessary for a parts changeout or if there's an issue and you wanted to use the diagnostic troubleshooting. But that is the basic changeout to go from one part to another. Now, if the part is substantially different in size, you might need to change this module out. I'm going to bring the camera around to the other side now, and I'll show you a little bit more of what these modules look like, actually. We're looking at this side of the machine. You can see, hopefully, a little bit more of the cabinet. This is the knob that controls the vibratory bowl speed. This controls your grip. There's a gauge above it. This is the main air regulator for the air coming in. It also acts to clean and dry the air, which is very important because if you have oilers in your system, it will get gunk all over the machines because we use air to feed the parts, and we use air gates to remove the parts from places we don't want them. But you'll also see, if I get in here close enough, that this entire module here behind the arm comes off with 2 bolts. The whole thing is designed to be easily removed and replaced. So switching between vastly different sized parts should be pretty straightforward and should not take very long. The prototype that some of you might have seen a video of had the cabinet here, and it made that change out a lot more difficult. But we very much wanted to make this fast and easy, so we redesigned the entire machine to make everything accessible. This mechanism up front is our patent-pending twin fire, which allows the dual direction fire of the parts. It's a neat little piece of mechanism here, but ultimately it is even more versatile than the escapement up here. The twin fire here is set up for 20 gauge parts, but it can really be used for just about anything that is long enough that it doesn't have the ability to rotate in the tube passage. We have used this system to run parts as small as the Harwin geckos, and I'll get some videos up of that soon, I hope. But when you get down to parts that small, you want a twin fire mechanism that's sized for them. But if I was to switch out to running 20 gauge parts, I can run 20 gauge parts 22 gauge parts. I can run those parts in a 20 gauge escapement because they're smaller than the apertures, and they go fine through the twin fire. What I would need to do is change out to this positioner to make sure that that much smaller part is properly centered for a good spec crimp. So anyway, that's the basic theory of this machine. We are going to be doing a lot more videos about this to show its versatility. And of course, this is the benchtop version designed to be used by an operator. We are in process developing one to be integrated into the machines made by the Comax group. And we're very excited about that because just like for benchtop use, the one machine that can run all the parts, when you combine that with the incredible processing power of the Comax wire stripping and cutting machine, you now have the ability to strip, cut, and terminate a whole world of MILSPEC parts without having to buy an applicator for each one of them. So stay tuned, that's coming next. But for now, this is the production version of the UNI-CRN, our universal crimping system, and we think that it might be the first machine in this space to actually live up to that name.